Welcome to another episode of Exploring Mathematics. Today we're going to do part 2 of data. If you remember last week, we discussed how to use Desmos to enter data, graph data on a dot plot, a box plot, a histogram, interpreting data basics, visualizing outliers, and interpreting the numbers that you see on the graph. So today, we're going to have 5 little sections that we're going to do. Our first section is the 5-number summary. What we're going to talk about, I'm going to give you a little example of a family reunion. Right here. Let's say a family gets together, first time in a long time, and they have a reunion. And all the people in the family, they gather and they decide to line up. They could line up by height. They could line up by the length of their hair, the size of their shoe, whatever. They choose to line up by age and take a picture. If you look at these numbers, you'll know that there are 20 members of this family that came to the reunion. The youngest one is 3. The oldest one is 94. You already know how to put it into Desmos. You did that last week. This week, we're going to talk about what the numbers mean that you're looking at. So minimum, this is your smallest number. Well, that's right there. Maximum is your biggest number. That's easy to find right there. Arrow is not working very well, but that's an arrow. There we go. These are the other numbers, quartile, median, and quartile 3. All right. If I look at the graph that you know how to do this, you did this last week, right? I can see, okay, that 3, this is the 3. And this is 80, 85, 90, 90. This looks like the 94. All right, where are they getting these other numbers here? I'm going to use my pointer to show what I'm looking at. Where do they get this number, and this number? These are these 3 in the middle. So on Desmos, I'm going to show you the next button. I want you to go to Stats on Desmos, and the Stats button on the Stats chart, and type the letter of your table, not your table, your set of data. So I'm going to call this the alpha family. The alpha family has a 3-year-old and a 94-year-old in it. I put all the data in. I said stats A. And this is what I got. I got the 5-number summary. So this is how I'm going to try and describe it to you. If you're into sports, it's very easy to think of it like this. The first number is the kickoff, or the start of the game. Quartile 1 is the first quarter, or 25%. Median is the halftime, or the 50th percent. Quartile 3 is the third quarter, which gets you to the 75th percent of people. And the maximum, that's the end of the game. That's the game's over, full time. Everything's done. What they're saying is in this zone, and I'll choose a new color to make it easier. I've got 25% of the people right here. I got 25% of the people right here. 25% of the people there. I know in a football game, the last 2 minutes can take an hour, but really, it still is only 25% of the game. So your first quarter, your second quarter, then you get your halftime right there. Third quarter, fourth quarter. The total is your whole game, or all the people all the ages of the people at the reunion. That's what I need you to understand about the 5-number summary. It breaks your data into 5 numbers. So I want to compare how this looks with our data set. Okay, we did it. The min is 3. Got that. That was our youngest person. Q1 is 10. Let's look up here. Where's 10? 10. Okay, I got these 10s right here. Here's a 3. 30. 30 is, oh, it's in between these two. And the Q3 was 43. Where do I find 43? 43 is in between these two. All right. If I'm breaking this family into 4 groups, 25% each, there's 20 people divided by 4. There should be 5 in each group. So I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now there's 5 people in each group. And I can see the 30, I'll point to it. This 30 is the average of these two. This 43 is the average of those two. If you have any questions, replay the video because that is the key to the 5-number summary. Looking at the graph, you cannot tell how many people are on this graph, but you know that 25% of the data is in each section. There could be 100 people here or 1,000 people. In this situation, it was 20. Next page. Now I want to talk about the mean versus the median. If I go back to the story of the family, that was this one right here, the median was 30. The mean is 32.5. Median is, remember, the middle number. The mean, also known as the average. The symbol. Well, on some calculators, you're going to see this symbol. It's called X bar. But you're also going to see it written as mu. This is the Greek letter mu. Okay, it's a lowercase. It looks just like that. Looks kind of like an M, looks kind of like a U. That's the symbol. Don't worry about it. It's going to show up in our displays, but you're not going to have to use it. Now, median and mean. When do you use which one? Okay. Last week we talked about how data looks. I'm looking at these two graphs on the screen. This one, remember we said, is symmetric. And this one is skewed. Skewed right. It doesn't matter if it's right or left, but if it's skewed, you're going to use the median. If it's symmetric, you're going to use the mean. Why is that? Well, when the data looks kind of funky, like this, it's got skewed over here. If you take the average, so here's your median, right? Your mean is going to be somewhere around here. Is that really the middle of the data? Because what we really want to find is the center. Center of the data. There we go. Looks better. We want to find the center. In this situation here, the center is very easy. It's right, bam, it's in the middle of this is called a bell curve, this shape. It's a standard bell curve in the middle. That's easy to find the center. On this one, on the right, I can't tell where the center, I mean, if I'm looking at this data, yeah, the median is probably the center because half the people are here and half the people are here. That's a good way of looking at the center. Oh, let's go back to this. When to use which? If it's skewed, you're using median. If it's symmetric, use mean. There'll be some questions on our assignment to go with this. And I want to look at, this also is a good example. You learned these three words, mean, median, mode, back in 6th grade usually. We're not, in this drawing, mode is the most popular. Well, the top of the hill, or the top of the data, is your most popular number. But that's not the center, really. I mean, it's most popular, but look, there's only a few on the right, and there's all this stuff on the left. So we're going to say if it's skewed, it's going to be, we're going to use the median. We're going to go a little bit down the hill and say, this is the middle of the data. Half of it's here, half on the left. If we go to mean, well, it's now, there's only a little bit here and a lot of stuff going on over here, so the mean would not be fair. If you're dealing with a symmetric graph, the mean, median, mode are all the same number. Ooh, that's a good one to write. When it's symmetric, they're all the same number. So if you're dealing with symmetric data, the mean, the median, and the mode will all be the same number when it's symmetric. These are skewed, left skewed and right skewed, and a little bit different. Our last thing we're going to do, real estate example. Okay. So this is data for the month of March 2020, right here. I'm looking at the top of the page. This is the houses that were for sale and sold in Sacramento County and City of West Sacramento during the month of March 2020. Now, the data might be a little skewed because we went into lockdown in California at the end of the month, I believe. But we can still compare data. Like listings published this month. How many houses were put up for sale? 1,755. The month before was only 1,517, so it went up 15%. The year before, March of 2019, it was 1,815, so it's actually a change from the previous year of minus 3.3%. There's a ton of data in here. I'm going to look at this part down here. I'm going to actually circle it so you can see it better. Circling in a light color. The median and the mean. The value of the houses that sold, closed escrows, those are the houses that sold, this word, closed escrow. So that means the property changed hands. So the median price of the houses in this, the total value is $508 million during the month of March 2020. But the median house was $400,000. The mean, or the average, was $432,000. I can now ask you a good question. Is this data skewed left or skewed right? Because remember, I said earlier, if the data is symmetric, these two numbers will be the same, but they're not. So it's going to be skewed right or left. Well, which one's bigger? So the mean is bigger, right? The mean is bigger, so let's go back up to this graph. When the mean is bigger than the median, it's skewed right. The mean determines which direction the skew is going compared to the median. If the mean's on the right side, it's pushing right. If the mean is on the left side, I'm over here on the left, the mean is pushing it left skewed. Okay, this is data that you might use. Now, a lot of people are really great, successful real estate salespeople, but if they understand data, they can be even more successful. And that's what I'm hoping you get out of this. All right, next page. Part 3, IQR versus standard deviation. IQR and standard deviation. We're looking at these two questions. How spread out is the data and what is normal data? I mean, that's what people who study data, that's all they really are talking about is what's normal and how spread out is it. Whether it's the data about how many points a basketball player scores, or how much, how many houses sell in the city of Sacramento or the county of Sacramento. They just want to know what's normal. So we're going to talk about that. If it's median, if you're using the median because the data is already skewed, we're going to do something called the interquartile range. And we saw that a little bit on the last slide. It was this picture right here. I'll just jump back to it so you can see it. We looked at it, didn't really notice it, but here it is, IQR. Same graph. The IQR is basically saying it goes from here to here, which means how far is it from Q1 to Q3? So IQR, interquartile range, that's what it stands for, interquartile range, is equal to Q3 minus Q1. In this case, it's 43 minus 10, which equals 33. So on our example of the alpha family, with the youngest child being 3 and the oldest grandparent being 94, their IQR is 33. 33 years apart is their center of the data. So that's how you calculate it. Now I want to talk about standard deviation. Standard deviation is used with the mean. It's not used with median or anything else. They always go together. Standard deviation and the mean. So if I have the mean, the symbol for standard deviation is, it looks like this. It looks like an O with a little thing on the end of it. It's called sigma. You don't have to know that. It's another Greek letter. That's a lowercase. If you want to know something cool, here's the uppercase. You might see one of those around. They're both sigma. But this is standard deviation. I'll write it again. Standard deviation. Standard deviation. Standard deviation. What that says is the normal data, and there's a formula down at the bottom of the page I'm going to show you. The normal data is how far from the mean, or the average, remember? So the average, if the average is here, the standard deviation is how far from there. So it's going to be a plus or minus. Here's our mean, the average. One standard deviation up, one standard deviation down will give us 68% of all the people in that data. Well, that's pretty good. I mean, you've got majority. Over here in IQR, you only have half the people, 50% in the IQR. Here, we've got 68% of the people or the data points in the first standard deviation. So what they're going to say is, and I'm going to show you this. It's going to be like, not here. Next page. But then you can have a second standard deviation. Here's your first, second, third. Or you can go down 1, down 2, down 3 standard deviations. Each one of these is another standard deviation. Here's 1, here's 2, here's 3. Or -1 standard deviation, -2, and -3. The more standard deviations you go from the center, the more data will be included. The first standard deviation will get you 68%. And then the third one, 99.7% of all the data should be within 3 standard deviations. So if this is money, okay, out here you've got Bill Gates and Warren Buffett and Jeff Bezos. That's they're way out there. Okay, so we did a visual example, and now we're going to talk about how to do it on Desmos using sample and population. Okay. When you go to Desmos, you're going to hit the stats button. That'll calculate stuff for you. Standard deviation, this one is the sample. This one is the population. What does that mean? In our data about this family, the 20 people in the family, we know the ages of everybody at the reunion. We know the whole population. Therefore, we're going to use this one. If you go around your school of 100 or 2,000 students, whatever it is, and you interview, 30 people, 50 people, and say, what's your shoe size? Or how many concerts did you go to last year? Or how many hours do you normally work at your job during the week, right? You don't have everybody, so you're going to be doing a sample. Sample is when you have some of the data. This one is you have all the data. All right, now I told you at the bottom page I was going to show you something. This is the formula for finding out standard deviation. Really cool. You don't have to learn it. People my age had to learn it, how to do it by hand or with a calculator. Don't sweat it. Desmos does it. Right here, Desmos. You hit the stats button. We're going to be using this one because I'm going to give you all the numbers. When you do your own stats, when you interview people, you're going to use this one, the sample. I was going to look at this one right here about the cookies. And this could be, they interviewed a whole bunch of people in 4 different cities. How many cookies do you eat in a normal week? And in this city, these 3 cities, the blue city, the red city, and the yellow city, the average was 10 people. Or 10 cookies, sorry. 10 cookies per week. In this green city, they ate only 6 cookies per week. Now, the blue city, it's like everybody eats either 9, 10, or 11 cookies because they're in this zone right there. That's not everybody, of course, but it is the majority. That's one standard deviation. In the red city, well, maybe they eat 8 to 12 cookies or 7 to 13. That's one standard deviation. This yellow city, 6 to 14. So you see how the standard deviation, these cities, we're going to compare them on the next page. Just want to give you an example of what it looks like. Now, applying standard deviation, given the mean and standard deviation, be able to find points that are normal and outside the normal. Now, if you have median, you would find what's known as the lower fence and upper fence to find out what the normal is. And there should be another P in there. So I'm not going to ask you to do this today. I'm just going to give you the numbers and say, well, what can you do with this? So given the mean and standard deviation, I'm looking at our goal here, be able to find points that are normal, and outside the norm. For example, let's say the average age of people who play cribbage or whatever it is 48 years old. The standard deviation on this is going to be, I don't know, let's make it up, 3 years. That means that 48 plus or minus 3 is 1 standard deviation. Plus or minus 3 again is 2 standard deviations. What they normally say is 2 standard deviations is going to be normal. So I'm looking here on this graph that we're about to do for something else. So if I take 48 plus 3 and plus 3, I get 51, 54 years old. Minus 3 and minus 3, that's minus 6. 42 to 54 years old. I'm making this data up, but I can say if the average age of people who play cribbage is 48 and the standard deviation is 3 years, then this is normal. What would not be normal? Give me a number that would not be normal. That'll be in your assignment. Now, how does this work in the real world? I'm looking at clothing companies, shoe companies, whatever, people that make stuff, they're looking at data all the time. Some companies only make their clothes for one standard deviation. They take the average man or the average woman, and they'll say, well, we're going to make shirts, and the shirts are going to fit these people. Now, or they might even only say, we're going to fit these people. Just one standard deviation up from the mean or down from the mean. These might be bigger people on the right. These might be smaller people on the left. The average height for a man in America is like 5'10" or 11. For a woman, it's about 5'7" or 8. And they design the clothes accordingly. Now, if you're Levi Strauss and you're making jeans, maybe what you're going to do is you're going to say, we're going to make clothing for these people here. That way, we're going to get 95% of the people will be able to buy our clothes. The smallest jean size might be 28 inches. The biggest might be 48. So if a person has a 58 or 60-inch waist, they may not be able to go to Levi Strauss because it's not worth it for the company to make clothes for every single person or shoe size. Does Nike want to make size 26 shoes for the 9 people in America that want to buy them? No. So they're going to decide where to make their shoes. That's what I want. This is where the real world is. Real world use of data. Okay. We have one page left, and this is comparing 2 sets of data. When you want to compare 2 sets of data, and we've got this one from a couple pages ago, you want to look at the data. Okay, I can look at the graphs. I can compare all 4 of these. These don't have to be cookies. These could be any sort of information. This could be like, what's your income in various cities? So these 3 cities, the average person has pretty much the same income. But in this city, the blue one, people's salaries are very tightly grouped. But in this yellow city, the salaries go way down or way up. A lot of variation in there. And in this green city, the average salary is a lot lower. Does that mean the green city people are all worse off? No. This person right here, these people right here are better off than these people here, because this green person, there's some people that make just as much as the average blue, red, or yellow person. They're out there. But there's very few. Okay, so look at the data. Graph the data with box plots. Here we have, remember this? Family A, alpha. Well, I made a family B for Bravo. Looking at the 2, graph them both with box plots. See, compare them. What will you compare? Is the data skewed or symmetric? Well, they're both skewed to the right, because here's the middle of the data, right? But it goes really long out here, really short on the left-hand side. Compare the middle numbers. Well, this one is lower than this one, so the Bravo family seems to be younger than the Alpha family. Compare the spread of the data. Okay, this IQR is about the same as this IQR, maybe a little bit less. That's what you say. You describe it, just like you describe this data. The data spread here the spread is really tight compared to this one, which is tighter than this one, the red one, which is even tighter than the yellow one. The yellow is the most spread out data. Compare the spread. The last question is, what's your objective? Are you trying to buy a car? Are you trying to create a new medicine? Are you looking for a job? Are you looking to hire somebody for a job? Are you um, the salesperson or a sales manager for a company? Who's your best salesperson? Are you looking for investments to where to put your money? Are you debating with your friend your favorite sports teams? If these two graphs are not families, but they're sports teams, and it's how many points they score in games, I'm going to look at this and go, well, this team scores has had a really good game compared to this team. The middle of this team is way above the middle of this team. I think this A team is better than the B team. That's how you look at data. What's your objective? And I think that's everything. I'm going to put some questions on the end of onto the Edpuzzle. Hope you enjoyed the video.